just like matrices can be added together, matrices can also be multiplied. Now, if I want to take a matrix and multiply it by a single number, that is something that we call scalar multiplication. We're going to scale every element within the matrix by whatever number it is being multiplied by. So, my first element, 1, 1, is 1, and that's going to be multiplied by 8. So it becomes 8. And then likewise throughout the entire matrix, 8 times 2 would give me 16. 8 times 3 would give me 24. 8 times 4 would give me 32. And notice how they're all corresponding to each other. That is how you multiply a matrix by a single number. However, we're not getting off that easily. Multiplication of matrices can also happen when you have two matrices. So one organization and table of numbers, and then against a second table of numbers. Order matters in this case. So we're going to take A, the matrix A, and we're going to multiply it by matrix B. So there's rules that you have to follow, but it's pretty logical, but it's also kind of complicated. To multiply a matrix by another matrix, you need to do something that we call the dot product or vector multiplication of rows and columns. So what that means in normal language is that we're going to be multiplying matching members of the matrices, and then we're going to add them up. So in order to get my answer element of 1, 1, I need to match up the numbers from both matrix A and matrix B. Now my answer element is in row 1, column 1. So because I say row first, I'm going to go to matrix A and I'm going to highlight that first row. Likewise, I'm going to highlight the column 2 in matrix B. Now the members or the elements that make up both of this row and this column is what's going to give me my answer element. I need to match those members up. So my first element in my first row is 2. That's going to be multiplied by the first element in the first column, 2. 2 times 2. And then I'm going to move on. What matches with 4? Well, that's 3. So I'm going to add them up. We'll simplify everything once we're done. The second element that I need to find of my answer matrix is going to be in row 1, column 2. So I need to find my first row of matrix A. Well, that's highlighted again. So I need to find my column 2 of matrix B. And that's right there. Following the rules, I'm going to be multiplying matching members of the matrices, matching elements. So what does 2, my first element in matrix A, row 1, what does that match with in matrix B? That's -1. Continuing, 4 now is going to match up with -1 again. So as we moved, first element in that first row matched with the first element in that second column. The second element in my first row matched with the second element in that second column. Now let's see if we can find our third element with a little bit easier method. So again, this third element in my answer matrix is known as 2, 1. So in my first matrix A, I'm going to highlight my second row, and back in matrix B, I'm going to highlight my first column. Find the elements that match together, 1 and 2. We multiply them. And then we're going to add them to the elements that match in the second, 7 and 3. And then finally, my last element in my answer matrix is element 2, 2. So I use my second row and my second column, respectively, of matrix A and matrix B. 1 is going to match up with negative 1. They're the first elements of the second row and second column. I'm going to add them to the second elements of the second row and the second column, which is 7 and negative 1. So there was a lot of communication going on, but what we really did, slowly and surely, is that we matched each elements, multiplied them, and now we're going to reduce them and simplify the expressions inside each of the elements. So, looking forward with this simplification, I can see that 2 times 2 is 4 is going to be increased by 12. That becomes 16. So I can see my orange element, or element 1, 1, is 16. My second element, my green element, which is 1, 2, is 2 times negative 1 is negative 2, is going to be increased by 4 times negative 1, which is negative 4. Simplified becomes negative 6. My third element, 1 times 2 is 2, increased by 7 times 3, which simplifies to 21. And that whole element simplifies to 23. And then finally, my last element, 1 times negative 1, that went a little fast, so I'll back up. 1 times negative 1 is negative 1, is going to be increased by 7 times negative 1, which is negative 7. Add them together, and you get negative 8. So I'm going to take away all of that little extra stuff and highlight it a little bit more. And what you can see is that my answer from multiplying matrix A by matrix B is another 2 by 2 matrix. It's simplified nice and easy. And I understand and I know that the process was a little complicated. But if you can think of multiplying matching elements and then combining them through addition, you are going to find that multiplying matrices really isn't that hard. But my question is it commutative? The addition of matrices was commutative, but do you think that order matters when we are multiplying matrices? Well, in fact, it does matter. That is the answer of B times A. I did the work for us, is 3, 1, 5, 5. It is not commutative. It is a completely different answer than our A times B. So multiplication of matrices are not commutative, but you can do it. It's important to know that A and B, whatever matrix comes first, determines the rows and then the columns that you'd use. Oops, went too far ahead. The rows and the columns that you would use. So if B were to come first, I'm actually going to use this whole... I am messing up all over the place. And I completely lost my spot, and there it is, and I'm so sorry for that. So as I was saying, the row is determined by your first matrix. So having B comes first would mean that I would be using that row first in my multiplication process and this column first in the multiplication process. So just to reiterate that multiplication of matrices are not commutative.